Yes, students, good morning. So, day 3 today, we are starting. And day 3, what we want to do? Motion in 2D. Okay? Motion in 2D we want to do today. Motion in 2 dimension or motion in plane. So, how to do motion in plane? What is the meaning of that? Its meaning is the object is going to travel along x-axis also and y-axis also at the same time. So, it becomes complex then? No, it's very easy. How? Let's talk about, let's say we have acceleration along x-axis, say ax. What this is going to do? It is going to change velocity along x-axis only. Velocity along x-axis. What it will do? Change velocity, not velocity along x-axis, change velocity along x-axis. And this will be responsible for displacement along x-axis. Displacement along x-axis. It has nothing to do along y-axis. What is happening along y-axis? This is not responsible for that. Then who is responsible? Acceleration along y. Okay, acceleration along y, what it will do? It will change velocity along y-axis. And this will also be responsible for displacement along y-axis. Okay, both separate. You don't have to mix them up. Right. Let's do a question, you will understand it. Through questions only we will understand it more, right? So let's see, let's start. Simple question I am giving. Very simple question. What is a simple question? Let's say an object moves 3 meter towards north. Okay, 4 meter towards east and 5 meter upwards. Then what we have to do? Find its displacement. Find its displacement. Okay. So, what I am going to do now, when I am going to solve it, I will solve it by first defining the axis. Okay, like this it is. This will say east, this will say north, this is west, and this is south. Now, this is also x-axis for us, and this is y-axis for us. Now, what about the upward then? This is not upward, this is all horizontal. Okay, east, west, north, south means not upward. Okay, if suppose this is east, back side means west, this side is north, this side is south. These are horizontal directions. Upward is like this. So here upward will be like this, along z-axis. Here, this pen represents z-axis. Okay, towards you. So this is upward. So how will I write? The particle starts from here. Okay, it has gone where? It says it has gone north. So it has gone north like this. How much? 4 meter. Sorry, 3 meter. Along north, 3 meter. Then along east, 4. And then again from here, you came here. Right? So 5 meter you have traveled here. So he is asking displacement. This is your initial point and here is your final point. So this we have to combine. So how to write? Displacement vector we will write. This is 3 meter. So along y-axis, I will write this as 3j cap. Then along x-axis 4, so I will write it 4i cap. And along z-axis, positive z-axis is 5. So I will write it as 5 cap. Properly you write 4i cap plus 3j cap plus 5k cap. So displacement will be what? If suppose we have to find its magnitude, then we know that it will be 4 square plus 3 square plus 5 square. This will be the magnitude. Okay, so what we did, we took all separately. Along x-axis we talked separately, along y-axis we talked separately, along z-axis we talked separately. Only displacement at the moment, but we talked separately. Okay, so when we are going to talk about 2D motion also, there also we have to talk about them separately. Okay, one more question we will do similar. Now see in this one what we want to do. Similar question I said. So in this one we will talk in terms of components also. What do you do? Say a particle moves along east by 8 meter. Then it moves 60 degree north of east. Then it goes 60 degree north of east by 6 meter. Then upward also. Okay, leave it. Find its displacement. Find its displacement. Right. So now what? Let's see. So what we have done? Now everything we have taken this time in 2 dimensions. There is no 3 dimension. No upward, no downward. Okay. Only east and north. So if I am going to make that this is east and this is north, and how much it has moved? East by 8 meter. So okay, fine. East by 8 meter. So east like this 8 meters. Then what he says? 60 degree north of east. That means from east towards north 60 degrees. 60 degree north of east. 60 degree towards north from east. So that means like this. Like this you moved. And this angle is 60. 60 degree north of east. How much you moved? 6 meter. So that means you will be somewhere here now. This is the final point and this is initial point. Now you have to find the displacement. Now how to find? This we have to find its components. That means we have to find how much it has moved along east and how much it has moved along north. So if I have to find how much it has moved along east, what I have to do? Okay, it will drop a perpendicular here. This much it has moved along east and this much it has moved along north. Can you find it? Yes, why not? This is 6 cos 60 and this is 6 sin 60. 6 cos 60 and 6 sin 60. That's it. Yes. So displacement, what you will write? You will write displacement as 8 plus 6 cos 60. That is along east. So you say I cap and plus 6 sin 60 j cap. That's along y. The total if you have to find 6 cos 60 means 3. So 11 I cap and 6 sin 60 will be root 3 by 2. So 3 root 3. And suppose we have to find its magnitude. Okay, no issues. Magnitude if we have to find, then it will be what? 11 square plus 3 root 3 whole square root. And that will be the magnitude of the displacement. Correct. So if it's given in terms of angle, then also we can solve. Without angle we solved already. Correct or not? So this is 2-dimensional motion. This is 2-dimensional. Previous one was motion in 3 directions. That means you are having x-axis also, y-axis also, z-axis also. Okay. Particle was moving along all the axes involved. Right. Okay. From here what we learned then, what we can do. Now let's see. Now I am giving that, let's say our displacement is variable. That means I am giving, let's say, 3t cube I cap plus 2t square j cap. It's given like this. S is equal to, this is vector, 3t cube I cap plus 2t square j cap. This is displacement along x-axis, this is displacement along y-axis. What we have to do? We have to find velocity and acceleration. Okay? Find velocity and acceleration. At what time? At any time we can say, at t equal to 1 second, let's say. Okay, so when we talk about velocity, what is velocity? We learned it already, right? Velocity is basically ds by dt. And acceleration? Acceleration is dv by dt. And dv by dt means what? d by dt. And this v is what? ds by dt. So ds by dt. That means d square s by dt square. Double differentiation. That means if s is there, then we have to differentiate it double to get acceleration, right? And single differentiation, we are getting velocity. Let's do. Okay, so let's talk about velocity. Now, what I'll do, I'll find first velocity along x-axis, then I'll find velocity along y-axis. Okay, so in this one, displacement along x-axis means this. So I'm writing it like this one. Displacement along x, it is 3t cube. Okay, so velocity along x, d by dt x sx. What we are going to get? 3 will be as it is. Differentiation of t cube will be 3t square. So 3t square. What we got? 9t square. That's velocity along x-axis. Same way velocity along y-axis we'll find here. Okay, so velocity along y-axis means what? d by dt of displacement along y-axis. What is that? 2t square. Differentiate that. 2 will remain as 2. T square's differentiation 2t. So what we got? 4t. So velocity along x-axis in 1 second. You can see that this is velocity along x-axis. At 1 second, what it will become? Velocity about x at t equal to 1 is 9 meter per second. And velocity along y at t equal to 1 second. What is that? 4. Both separately we found. Now, said acceleration. Okay, acceleration along x-axis. Let's find acceleration also. What we have to do for acceleration along x-axis? We have to differentiate velocity along x-axis. What is velocity along x-axis? 9. That is at t equal to 1 second. We have to find velocity along acceleration along x-axis first. So, we will write velocity along x-axis, which is 9t square. Okay, don't write 9 because this is at a particular instant. Particular instant we will do after placing it. Okay, so here also first find in terms of t. This is velocity along x-axis. Put it. So, d by dt of 9t square. So, 9 will remain as it is. Then differentiation of t square. Differentiation of t square is 2t. So, acceleration along x-axis is coming 18t. Now, at t equal to 1 second, it is 18. Right? Acceleration along y-axis now. Acceleration along y-axis means d by dt of velocity along y. What is velocity along y? Where it is? Here, 4t. Velocity along y is 4t. Put it. d by dt of 4t. So, 4 will be as it is. Then differentiation of t is 1. So, that is 4. So, here it is constant because it is not changing. There is no t in it. So, acceleration along y-axis is 4, constant acceleration, whereas acceleration along x at t equal to 1 is 18. At t equal to 2, it will be different. So, along x-axis variable acceleration, along y-axis it is constant acceleration. Now in this one you see that everything we solved in a different way for x-axis and y-axis. We did not combine. In 2D motion also we have to do in the same way only. Everything separately. Okay, that is only the clue of solving 2D motion in easiest way. Okay, I hope this is clear to you. If you want to solve one more question, we can do a similar question if I say. Okay, but we will not go that long. Okay, s equal to 2t square I cap plus 3t j cap. Okay, only we will find velocity. Find velocity at t equal to 2 seconds. Okay, let's do very fast. Solution, what you will do? X and y both separately. So Vx is what? d by dt of displacement along x, means displacement along x is what? This. So d by dt of 2t square. Okay, so 2 as it is, then differentiation of t square 2t. So 4t at t equal to 2 seconds. 4 into 2, that is 8. Done, over. Okay, now then Vy dy dt of displacement along y, position along y. So d by dt of what? What is there? 3t. 3, then differentiation of t with respect to t, 3 only. That's it. It's constant. Along y-axis velocity is constant, whereas along x-axis it is 4t, but at t equal to 2 seconds it is 8. Okay, clear? Now let's see. The first thing that we are going to do is river boat problem, river crossing. River crossing. River crossing, what happens? Now this is river. This is the width. Okay, and river is flowing like this. You want to cross the river. From here is you want to start. And directly I am going to talk about the two cases on which the questions are asked. Okay, I am not going into it in a lengthy way and explain you a lot of things. No. Main two cases we will be solving. Okay, so what are the two cases? Two cases that we have are, if you want to go for shortest distance or you want to go for minimum time. Okay, all right. Now let's talk about a man who is going to swim in that one. So whenever we talk about a man which is going to swim in the river, his velocity will be always with respect to river. Okay, it's very similar to if suppose that we are talking about a bus. When you are inside the bus, if you are moving inside the bus, your velocity will be with respect to bus only. Okay, it will not be with respect to ground. On the ground, if you are walking, it's with respect to ground. But if in the bus you are walking, with respect to bus. Exactly same way, once you jumped in the river, your velocity will become velocity of man with respect to river. Remember that. Okay. So first case, which one we are doing? The first case I am going with minimum time. Minimum time taken to cross the river. Minimum time taken to cross the river. Okay. So minimum time taken to cross the river will be what? When we are going to move perpendicular to the river velocity. When we are going to move perpendicular to river velocity, then we are going to get minimum time. Okay, why? Because your total velocity will be in the direction of crossing the river only. Right? Total velocity is like this, because ultimately you have to cross the river. You have to travel W, which is along y-axis. If suppose I am taking this along y-axis, this is along x-axis for us, and this is along y-axis for us. Okay, so W is along what? Y-axis. Clear? So when I have to clear this river, my displacement has to be along y-axis. So if I put entire my velocity, whatever velocity I can have, all is along y-axis, then only I can travel in minimum time. Able to understand? If suppose that in that direction my velocity becomes less, then it will take more time. In terms of y-axis only I am talking, remember. This is y-axis, so my total velocity along y-axis. Then only you will be getting minimum time. So minimum time to cross the river is what? When man moves normal to velocity of river. Velocity of river. Now, once you are in the river, what will be your velocity? Relative. VMR. And that is only will be given to you in the question. Sometimes they will give you velocity of man with respect to river directly. Sometimes they will say velocity of man with respect to still water. Both are same. Don't get confused. If they are saying boat, they will say velocity of boat with respect to river. Sometimes they will say engine speed. Sometimes they will say velocity of boat with respect to river. Or still water are all same thing. Okay, don't worry. So velocity of man with respect to river is like this, VR is like this. So what will happen? Will he go directly at this point? No, not possible. Why? Because the river is going to push it. So where it will go? Not at this point, maybe somewhere here. He will reach somewhere here. Okay, not at point B, but he will reach at point C. What this is called? This is called drift. Horizontal drift or drift, anything. Okay, fine. Now the question is how much time it will take. Very simple for us. What simple? The time taken will be displacement along y-axis by velocity along y-axis. There is no acceleration here anywhere. No along x-axis, neither along x-axis nor along y-axis. Okay, so time will be what? We will say displacement along y by velocity along y. So what is displacement along y? W. What is velocity along y? VMR. Finished. This is only time. This is only time. Okay, then what is drift then? Okay, drift means along x-axis. Along x-axis. Okay, displacement along x-axis. So how much it will be? So velocity along x-axis into time. Displacement means Vt, because there is no acceleration. Or S equal to ut plus half at square. A is not there, so S equal to what? Ut. So displacement along x-axis is equal to u along x-axis into time. So what is u along x-axis? Vr. So Vr into time. Total velocity is what? Now here we have written total. In the previous case what we were doing, I written displacement in terms of I and j cap. Suppose here I have to write velocity. Velocity along I and j. What I write? Velocity of man. Velocity of man is what? Say Vr I cap plus Vmr j cap. This represents velocity of man. And from this diagram, what is the velocity? This is Vmr and this is Vr. So Vmr square plus Vr square square. See, everything is so simple. Along y-axis, when I am talking, I will talk only about y-axis. When along x-axis I am talking, I will talk only about x-axis, nothing else. What else they can ask? They can ask you this theta. Divergence, angular divergence, how much is that? So drift by width, tan theta equal to drift by width. Or in terms of velocity also we can find. In this direction, what is velocity? Vr. In this direction, Vmr. So tan theta is also Vr by Vmr. That's all. Whatever questions are there on minimum time, this is everything. Everything we have done. Okay. So now let's solve any question. If any question is given, how to solve? Just see that. How easily we can solve. Okay. The question is, let's say velocity of river is given to you as 3 km per hour. Okay, velocity of man in river is 5 km per hour. Okay, width is 500 meters. Width of river, okay. Width of river is 500 meters. Now what? You want to find minimum time. Find minimum time to cross the river. And what we want more? Drift and angular divergence. Okay, everything we'll find in this in one itself. Okay, so this is width here. This is 500 meter. From here you are starting. It says minimum time you have to cross. Okay, VR is here, and you are going to move in this way. VMR is your velocity. Okay, so first thing is time. Okay, let's get the time. So T. Now T equal to, along y-axis how much you have to travel? 500, and speed is what? VMR. Okay, so let's do. VMR is how much? 5 km per hour, but this is in meters and this is in kilometers. So either you convert it in meter per second or distance you convert in kilometers. Okay, so 500 meters means what? Half a kilometer. So half a kilometer by 5 kilometers per hour. Right, so what we are getting? 1 by 10 of what? Of an hour. You can convert this in minutes. 1 hour means 60 minutes. So 1 by 10 into 60 minutes, that means 6 minutes. 6 minutes it will take this man to cross the river. Done. Drift. Now drift is what? Drift is means you will not move here, you will be going here. So this is drift. Drift means is along x-axis. Who is responsible for x-axis displacement? Velocity along x-axis. That is VR. So that means VR into T. Now what is VR? VR is 3 kilometers per hour. So 3. And time has to be in hours again. So 1 by 10 of an hour. So 3 by 10 kilometers is the drift. 3 by 10 of a kilometer. 0.3 kilometers. 300 meters. That's 300 meters. And then what do you want? Angular divergence, theta. Simple. Tan theta equal to drift by width, or drift by width also we don't want to do that. VR by VMR, that is even more easier. Answer will be same, okay, don't worry. So tan theta equal to VR by VMR. What is VR? 3 kilometers per hour. What is this? 5 kilometers per hour. That's all. Done. Everything is done. Okay. One more question we will do. In that one, I'll try to solve it in a different way. See now. Okay. Again for minimum time only. So in this one, what is there? Let's suppose drift is given to you. Drift is, let's say, 400 meter. And VR is given to you as 6 km per hour. Okay, width is given, or shall we find width also? No, width we will be taking. Width is 500 meter only. Question is, find minimum time to cross the river by man. Okay, and is angular divergence. Angular divergence directly we can calculate. Why? Because drift and width both are given to us. Directly we can calculate. And minimum time only he is asking. So that means the same case that we have studied. Okay. So let's calculate. Now I am not making the diagram also. Okay, so tan theta equal to drift by divergence. How much is drift given? 400. So 400. And width is what? 500. So tan theta 4 by 5. Done. Angular divergence over. Now what? Minimum time is how much? VMR not given to me. I can calculate, there is no problem. But it's not given. So minimum time how to do? Now, see. In the previous case, width was given to you, VMR was given to you, we said width by VMR. But in this case, drift is given to you and VR is given to you. This is displacement along x-axis, this is velocity along x-axis. So what was the formula? If I go with the formula itself, drift was equal to VR into time. So T will be equal to what? Drift by VR. Drift is displacement along x-axis, VR is velocity along x-axis. Understood that? So in a different way. So what is drift here? Drift is 400. So I am writing drift by velocity along x-axis means VR. So 400 means is, you can say 0.4 kilometer or 4 by 10 of a kilometer by 6 kilometer per hour. So it is 4 by 60, that is 1 by 15 of an hour. That okay, both the things he asked, no? Divergence also he asked and minimum time he asked. So that means we didn't calculate even velocity of man with respect to river. Can we calculate? Yes, we can calculate. Tan theta is given. We have calculated tan theta. And tan theta is what? VR by VMR only, no? So if this is 4 by 5, VR is given to you 6, then can't we calculate VMR? Obviously we can. 30 by 4, 15 by 2. Done. Minimum time to cross the river. What is there? Nothing. So when you are talking about x-axis, talk about x-axis. When you are talking about y, talk about y. Don't mix them. Okay? Let's go to the other case. What is the other case? Minimum distance. Minimum distance to cross the river. Minimum distance means what? You want to reach exactly opposite point. Okay, this is river. This is width. The river is moving like this. Okay, now you are at this point. And where you want to go? Exactly opposite. This point. Okay. You want to go here only. Now we already have seen, if suppose that we go directly like this, river pushes us, then we reach over here. But this time we don't want to go there at all. So what we have to do? We have to cancel the effect of VR. Who is pushing us in this direction? VR. We have to cancel its effect. Cancel its effect means what? We have to make velocity along x-axis 0. Then only know you can move along y-axis alone. This is what? Motion along y-axis alone. Alone. When it's possible? When velocity along x-axis is 0. Getting it? So what we have to do? This is already pushing us. Then how we can make velocity along x-axis 0? We can move in this direction like this. Okay, we'll move it in this direction. What with speed? VMR only. Once in river, we are VMR. Okay. So we'll move in this way. We'll go with such an angle that we should have a component. Obviously component will be there. So in this direction what component will come? VMR sine theta. And in this direction what component will come? VMR cos theta. So we will move with such an angle that VMR sine theta becomes equal to VR. Okay, both are in opposite direction. So what will happen? Velocity along x-axis is 0. Okay, how we have to move? We have to move in such a way that VMR sine theta becomes equal to VR. If it becomes equal, you will reach here. If it's not equal, somewhere else you will go. If suppose VMR sine theta you have increased, This VMR sin theta is more, then you'll go here. If VR is more, you will go that side. So what do you have to do? You have to make it 0. So velocity along x-axis should be 0, then only drift will be 0. Okay. So minimum distance to cross the river means is reaching exactly opposite point. Reaching exactly opposite point. That is drift is 0. Means velocity along x-axis is 0. Means VR equal to VMR sin theta. That means sin theta you know. With what angle we have to move? We already know VR by VMR. VR will be given, VMR will be given. Okay. Now the question is how much time it takes. For time, how much time it takes, what you have to do? You have to cross the river. How much distance you have to travel along y-axis? W with what velocity? VMR cos theta. Very simple. Time to cross the river is W by VMR cos theta. W by VMR cos theta. That is it. Over. Sin theta you found. Cos theta is here. That's it. Both the cases we have seen. Now let's do question on this also. Okay. So question says, let's see, VR is 6 kilometers per hour. VMR is 10 kilometers per hour. Width of the river is 1 kilometer. Okay. To reach exactly opposite point, find angle made by man with velocity of river, with river flow, and also find time taken. Okay, this is the question. Okay, we'll start solving. This is river. Okay, velocity of river is given 6 kilometers per hour. Then we want to go exactly opposite point. This is our initial point. This is the final point. You want to go there. Okay, this is given 1 kilometer. We know that we have to move in this direction. And this is theta. This is VMR, which is also given. This is VMR cos theta. So let's talk about time first. Okay, what will be time? Time is W by VMR cos theta. That means 1 kilometer by VMR is how much? 10 into cos theta. Cos theta I don't know at the moment. Okay, let's find theta also. What is theta? It is sin theta equal to VR by VMR. Correct only? Because VR should be equal to VMR sin theta, then only you will reach it B. What is VR? 6. What is VMR? 10. That means 3 by 5. So sin theta is 3 by 5, means cos theta will be 4 by 5. Sin theta 3 by 5 means 37 degrees. Theta 37. Cos 37 is 4 by 5. Let's put it. So T equal to 1 by 10 into 4 by 5. Of what? An hour. Okay, so this is, so what I am getting? 1 by 8 of an hour. So we got the time. But angle, he is asking angle also. But he asked the angle from river flow. So this theta will not work. That's not the answer. River flow is like this. This is river flow. Okay. The river flow is this. Yeah, this green. So angle is this. That means this is here 90, 90 plus theta. So your answer will come 127 degrees. Remember, this way they confuse you. 90 plus 37, it is 127 degrees. Clear? I hope river velocity, river boat, river man problems you can solve. Okay, like this only the questions are asked in NEET. So don't worry about anything, right? Okay. Now we are entering into projectile motion. Which projectile motion to start with? Horizontal projectile. We are starting with horizontal projectile motion. So horizontal projectile motion means we are going to project a particle from certain height. Okay, let's take certain height. Okay, and so from here we are going to throw the particle. Horizontal means you are throwing horizontally. So from here you throw it like this. This is ux, and maybe height h. So when we are going to talk about projectile motion, along x-axis there is no force, no acceleration. Acceleration along x-axis is 0. No acceleration along x. Along y-axis, gravity is there. So that means projectile is motion under gravity? Yes. But it's two-dimensional, that is all. Okay. So acceleration along y-axis is there. G is downwards. Right? That's it. So along x-axis, if acceleration is 0, so there will be no change in velocity along x-axis. Yes. Velocity along x-axis is constant. Then velocity along y-axis, acceleration is there along y-axis. So velocity along y-axis changes. Velocity along x-axis remain constant, velocity along y-axis changes. Okay, this is what we have to do, and both separately. Y-axis we will talk separately, x-axis we will talk separately. Then after that there is no problem in projectile motion. Let's see. Okay. So this is the basic information about that. Along y-axis this, along x-axis this. Let's see what happens. So the path of the projectile is like this. Okay. Now what I have to do? I have to calculate, suppose, velocity at this point here. What will be its velocity? Here. Velocity is in which direction? Like this. Maybe I'll say this is v. But I have to find what is this velocity. So what I do? I say that this velocity actually will be velocity along x-axis plus velocity along y-axis. Perfect. No doubt. But what is velocity along x-axis? Velocity along x-axis should be initial velocity along x-axis plus acceleration along x-axis into time. What is this? Equation of kinematics. But acceleration along x-axis we said 0. Yes. So Vx equal to what? Ux. Vx is ux. So that means along x-axis its velocity is same, ux only. Vy. What you can do? So suppose I am going to take this is positive y-axis and this is positive x-axis. My x-axis and y-axis are like this. I took y-axis positively downwards. So what will happen? Vy is there. So Vy, same formula, uy plus ay into t. Correct. Uy is what? When you are throwing horizontally, that means vertical velocity you have given is 0. Because you throw it horizontally, then how vertical velocity will come? Horizontal. So that means uy is 0. There is no uy. You didn't give it. Then who is making it to move downwards? Gravity. Acceleration is there. No? Okay. So then Vy is what? 0 plus gt. Why plus I have taken? Plus because I took y-axis is positive downwards. That's why. It's our wish, we can take. If you want to take it negative, you can take negative, then minus will come. Okay. Any difference in the answer? No, here minus will come. At the moment I am going to write it as plus. Okay. Nothing much. So Vy is equal to what? Gt. So what I'll write? I'll write ux I cap plus gt j cap. Whether you write plus or you write minus, magnitude will be same. Ux square plus gt square square. Doesn't make any difference. Okay, that's direction basically. There's no issue in that. So this is velocity. Now if suppose I want to find displacement also. Okay, no issues. Displacement also we can find. So Sx. Again what? Same equation of kinematics, ut plus half at square, but only along x-axis. So ux into t plus half ax into t square, but ax is 0. So ux into t. Same way sy. Okay, sy also we'll see. What is sy? And sy is actually h. Actually h it is. But let's write, if suppose we want to write it, so we'll write uy into t plus half ay into t square. So this is 0. It's half gt square. But sy is what? We all know h. So from here we got the time. Okay, time taken to move from here to here. How much is that? See, h equal to half gt square. So t equal to root 2h by g. This is time of flight for this. Time of flight. See how easy it is. Take every direction in separate way and solve. Nothing else. Okay. Then what else he can ask? He can ask you this angle. Angle with which it's going to strike it. Okay. So how to do it? First thing is we have to find velocity. What is velocity? Let's say v dash is the velocity. How to find? We know. This is how. Correct? Right. So this is velocity. Velocity means its direction is this. Its direction is this. Right. So let's do it here. Direction of velocity is this. So it is having x component. Yes, obviously, because this is theta. This is the x component. And this is having y component also. Yes. No doubt about that. So what we will do? How to find theta then? Tan theta equal to Vy by Vx. What is there? How? Because this Vy I can take here, no? Both are perpendicular. It's a right angle triangle. Tan theta equal to Vy by Vx. So this theta also we can calculate. Anywhere we can calculate. Everywhere we can calculate. Wherever you want. Here also. Yes, here also we can calculate this theta. And this theta again is Vy by Vx only. But V should be at this point. This V, not this V. This V means this theta will come. This V means this theta will come. Okay. And suppose here also we want suppose this alpha. So then V should be here. So its y component by its x component will give you the angle made by the trajectory, the path with horizontal. What is this angle? What is this angle? This theta is angle made by path of projectile with horizontal or x-axis. Very simple. Then range. Range also we will see. What is range? This is range. No? Horizontal displacement. But we have done already. No? Yeah. Horizontal. So this is range. Yes. Range, only thing is time you have to keep. What is time? This is time. Okay, so range is, what is range? Horizontal. So horizontal velocity into time. Ux into time, what is that? Root 2h by g. That's all. Over. Nothing is there. Then what more? Trajectory equation is there. Trajectory equation is there. Trajectory equation means what? Relation between y coordinate and x coordinate. Relation between y coordinate and x coordinate. Okay, what is y coordinate and what is x coordinate here? This is x coordinate only. This is x. X means is displacement along x axis. Y means displacement along y axis. So this is okay. So x I am going to write as, x coordinate is ux into t, and y coordinate I am going to write as half gt square. Sx and sy value, uxt into half gt square. Now what? T value take from here, say x by ux, and put in this one. So y equal to half g x square by ux square. Done, finished. Y equal to g x square by 2 ux square. This is trajectory. It's that simple. Able to understand? Everything separate and solve, just like what you are doing in 1D motion. Solve it in 1D motion only. You don't have to remember anything also. You can get it very easily. Everything you can get. Okay, see it from here. Everything separately we have done. We have not mixed up anything. Velocity separately, displacement separately, acceleration separately, and we are able to find whatever we want to in this one. Whatever we want, we can find. See, angle, range, time, trajectory, everything we have solved. Okay, so see it. Then we are going to solve the problems on this one. Few problems we will do. Okay, let's see then. And okay, fine. Question is, let's take height of the tower here. Height of the tower, let's say, is 40 meters. Okay, and we are throwing the particle 10 meter per second. Okay, particle we have thrown with 10 meter per second. Okay, then what we have to find? First is find time of flight. First question. Let me see that will come it properly. Okay, fine. Second question. Find velocity of particle at t equal to 2 seconds. Third, angle made by path of particle with horizontal. At t equal to 2 seconds. What else you can say? Range. Okay, find range also. Okay, these are 4 questions, and these 4 questions we are going to solve now. One more question you put, change in momentum also will write. Okay, 5th point is find change in momentum. Change in momentum of particle in 2 seconds. Change in momentum of particle in 2 seconds. Okay, so first find time of flight. right? So find time of flight means what? Time of flight is again you are going to travel vertically. Time of flight means you have to come down to the ground. Vertically, how much you have to travel? 40. What is your initial velocity in this direction? 0. Uy is 0. Acceleration is there, g. So what do you do? H equal to, or y equal to uyt plus half ayt square. What is, we have taken, suppose downwards is positive for us. This is x, this is y. Okay, so this is 40, this is 0, this is g, this is t square. So 80, 2 into 40 by g, which is 10. So t square equal to 8, t equal to 2 root seconds. Done. First question over. So did I remember the formula? Root 2h by g is the formula actually that we saw in 1D motion. Time of descent. Here also time of descent only. Root 2h by g. Any particle, if it is dropped from the top, time of descent is root 2h by g. This is also drop only because initial velocity didn't give, so that means drop. Okay, so root 2h by g. Then what? Velocity of particle at t equal to 2 seconds. So along x-axis its velocity never changes. We know that. Okay, velocity at t equal to 2 we are writing. Along x-axis its velocity will remain same. So directly I am writing vectorially. Okay, just see. Along x-axis, what is the velocity? 10. So 10 directly, 10i. What to calculate in that? Nothing. Only Vy you have to calculate. What will be Vy? Vy will be Uy plus Ay into t. V equal to U plus 8. What is Uy? 0. Ay is what? G, that is 10 into t. Vy is 10t. But at what seconds? 2 seconds. So 20. Done. Got it? Velocity. Now he wants magnitude. No issues. Root 10 square plus 20 square. That is magnitude. Root 500 over. Work is done. Then angle made by path of particle with horizontal at t equal to 2 seconds. I know what it is. Vy by Vx. Tan theta is Vy by Vx. What is Vy? 20. What is Vx? 10. So theta is what? 10 inverse 2 over. Then range. Range also we know how to find. Range is what? Horizontal displacement. No? Horizontally how much you are traveling? Horizontal, what is your velocity? Okay, so range, horizontal velocity into time, because acceleration is not there. Ux into t. What is ux? 10. And t is what? Time of flight. What is that? 2 root 2. So 20 root 2 meter. Finished. Range also we have done. Then change in momentum we have to find now. Okay. So change in momentum, when we have to find what we have. Momentum means what? Mass into velocity. Mass I didn't give you, no? Okay, let be mass as m only. So change in momentum means final momentum minus initial momentum. Okay. And delta p. So m v final minus m v initial. Okay. So mv final. What is mv final? Mv final. V final is this. If suppose at t equal to 2 seconds. Yeah, t equal to 2 seconds. So velocity at 2 seconds is this. So I am writing as it is. Okay. No change. M 10 I cap plus 20 j cap. What is initial? Initial is only 10 I cap because Uy is 0. Only 10 I cap. Okay. So So you can see that m10 I cap is cancelled here. What you got? m20 j cap or 20m j cap. Kg meter per second. All the questions related to horizontal projectile motion we have finished. See, very easy. Okay, very easy it is. How to solve it? Okay, one more question. Let's do. Okay, let's take a tower again. Our tower we are going to take as 80 meters. Okay, and projection you do with 20 meter per second. It's going to move like this. Okay, we know that it will move in this way. Okay. Now what? Okay. Right. So question is, if I say that somewhere in its path, when has traveled 40 meter horizontally. Okay. When horizontal displacement of the particle is 40 meter, how much is its vertical displacement? Okay. Find vertical displacement of particle if horizontal displacement is 40 meter. Question is very easy. What will do? Horizontal displacement he has given. Who will travel? With horizontal velocity only. What is horizontal velocity? 20. So, Sx ux into t. Half a t square also we should do, but a is 0. So, I am not writing. Sx is what? 40. Velocity is what? 20. So, in how much time it will take? Reach there? 22 seconds. Now, what he is asking? He is asking Sy. This is Sy. So, Sy is what? Uyt plus half ay into t square. What is uy? 0. Ay is what? G. T is what? 2 square. 2g. That means 20 meters. Vertically it will travel 20 meters if it has traveled 40 meters along x-axis. Okay. What else we can do? This angle I can ask you. What will be the angle? Vy by Vx. Okay. Again Vy by Vx. Vx is what? Always constant. It will be 20 only. Only Vy you have to calculate. What is Vy? Vy is Uy plus Gt. Uy is 0. This is 10. Time is 2. So Vy is 20 and Vx is also 20. So alpha is actually 45 degrees. Okay, that's horizontal projectile motion for you. Okay, then what next? Oblique projectile motion. Okay, so oblique projectile motion now. Oblique projectile motion is the motion from which actually we start teaching. You start from oblique. But what I did, I started from horizontal. Why? Because you already know about projectile. I don't have to teach you the basics. So now oblique projectile motion. Okay. So we are going to throw the particle with an angle. Right? You know that it will go in this way. You have thrown it with speed u with an angle theta. Horizontal component of velocity is u cos theta. Vertical is u sin theta. So we separated the velocities. Now again it's easy for us. Acceleration along y-axis is there, downwards. Acceleration along x-axis is 0, means velocity along x-axis constant, velocity along y-axis will be changing. Right? This is range. And this one will be maximum height. This is maximum height. So as I said that this is 1D motion only, but you take x separately and y separately, that's all. Okay, so if it's 1D motion, then h max we can write directly. H max, what is the formula? H max formula we got u square by 2g. Through 1D motion, u square by 2g. So u is what? The velocity with which you projected it upwards. So here with what velocity you have projected upwards? U sin theta. So u square sin square theta will write. U square by 2g. Yeah, u square by 2g. No change. Okay. Time of ascent? Time of ascent was u by g. U was what? Again, vertical velocity. Here what is vertical velocity? U sin theta. So u sin theta by g. Okay. Time of descent? Time of descent we found is root 2h by g. Here also, yeah. Root 2h by g. Because at the topmost point, its velocities are what? You have at the topmost point velocity along x, but velocity along y is 0 at the top. It is the top. Means you can't go further up, no. Topmost point means what? This is the maximum height you can reach. You cannot go further up. That means your velocity along that side has become 0. Now it's going to come down. So that means this is your initial velocity now. Okay. So like freely falling body. Now time of descent means freely falling body. So 2h by h. That is h max you say. Okay. Which is also equal to this. That is also we know. Yes. So time of flight. It was 2u by g there. So here it will be 2u sin theta by g. No change at all. No change. What about range? Range is what? Velocity, displacement along x-axis. So displacement along x-axis means it will be what? Velocity along x-axis into t, because the acceleration is 0. What is velocity along x-axis? U cos theta. Time is what? This is time. Range. Or this is written in another way. 2 by g. Now, 2 by g you have taken separately. U cos theta, u sin theta means velocity along x-axis into velocity along y-axis. U cos theta, u sin theta. So 2 by g, ux, uy. Everything we have done. Angle? Normally, this angle and this angle will be same. It will be same only. Okay. But if suppose I want to find angle here, then how to? Same Vy by Vx. Find velocity over here. Okay. Its y component, its x component, and 10 alpha is Vy by Vx. Okay, so 10 alpha will be equal to Vy by Vx. This is range. Then what else is there in this one? Everything we have done. Displacement, how to find displacement we saw in horizontal projectile motion. Here also same. Along x-axis separately. So along x-axis uxt plus half ax into t square. Ax is not there. So ux into t. Along y-axis uyt plus half ayt square. Okay, we'll see trajectory equation. The trajectory equation means relation between x and y. So see how I am doing. X is what? Displacement along x-axis, that is ux into t, because acceleration is 0. Displacement along y, uyt plus half ay into t square. But ui is 0, no, in this one it's not 0. In horizontal projectile motion it was 0, here it's not. So here u cos theta is ux into t, and here this one is u sin theta t plus half gt square. I am taking y-axis downwards. Okay, if y-axis you are taking upwards, this will become minus. So standard in books, y-axis is taken upwards. So our equation and that equation plus minus difference will be there. Don't worry. Okay. Now what? From here, t value I am going to take as x by u cos theta, and I am going to put in this one. So y equal to u sin theta into x by u cos theta plus half g x by u cos theta whole square. See trajectory equation here. So what it is? Say x tan theta plus gx square by 2 u square cos square theta. In books it is given minus because they have taken y-axis upwards is positive, we have taken downwards is positive. So that's why this change. Okay. This is trajectory equation. So how easy it is? Nothing is there. Right or not? Then, shall we solve questions on this? At least 1 or 2 questions. Okay. The question is, find change in momentum. We'll do. Okay. Find and change in momentum between initial and final point. Initial and final point of projectile. Initial and final point of projectile. Okay. Initial and final means like this. And this, let's say, is theta, initial velocity u. So this is u cos theta, this is u sin theta. Now we all know that here also angle will be theta, and here velocity, that is also equal to u only. We saw in 1D motion, with whatever velocity you are throwing, the same velocity is going to strike the ground. Here also same. So we have to find change in momentum. So what is initial momentum? See, I am writing. Mass is m. I forget the mass every time, right? Mass is m. So initial velocity is what? U cos theta I cap plus u sin theta j cap. Sorry, u sin theta will not be positive here, no? Okay, x-axis positive. This is y-axis positive. Normal we will take. Okay, there also some changes will be there. I didn't take that, right? If I am taking y-axis positive like this and x-axis positive like this, then there will be some change in trajectory. What? This will become negative because upward velocity. This will become negative. This will come negative. This is when you are taking y-axis is like this and x-axis is like this. Like this, they can ask you a question, remember that. Because everyone remembers x tan theta minus gx square by 2 u square cos square theta. You made this is downwards, equation became like this. Be careful, okay? Right, so here again I have made it back how normally standard is given in books. Okay, so this is what m into v initial. Okay, what is m is m, v initial means u cos theta I cap plus u sin theta j cap. initial momentum. Final momentum we are saying this is also u only, okay, and this angle is theta, so that means this is u cos theta still, and this is u sin theta only. So final momentum will be what? Final momentum is m vf. Okay, vf is what? U cos theta I cap, which is along x, and along y axis is minus, because we have taken y axis positive upward now. Okay, so plus u sin theta minus j cap. That's it, finished. So change in momentum means this minus this. Okay, delta p m vf minus vi. Okay, so this minus this, so you can see u cos theta gets cancelled. What we are having then? M minus u sin theta j cap minus u sin theta j cap. So minus 2m u sin theta j cap. That is the change in momentum. Okay, that will be the change in momentum. That is it. What else is there? Done. Projectile motion. Every concept what is there I have told you. Now you solve the problems as much as possible. You will get the difficulties, you will have difficulties, and ask me. Okay, so we will solve it. This is projectile motion for you. Then what else? Circular motion. Circular motion. Circular motion what? Two types of circular motion. Uniform and non-uniform. Okay, uniform circular motion and non-uniform circular motion. Uniform circular motion we will talk first. So when we talk about circular motion, okay, we know that if a particle is moving in circle, constantly its direction need to be changed. Okay, the direction who is going to change? Centripetal force. Centripetal force. The centripetal force is always acting towards center. So centripetal acceleration is always towards center. And this is responsible for changing the direction of the particle. Okay, so always towards center. AC, centripetal acceleration. What is that? It is actually equal to v square by r. And since I am talking about uniform circular motion, it's a constant speed motion. Constant speed. So that means at every point acceleration is v square by r and it's constant. Okay, it's constant in magnitude. Direction is changing, but magnitude is constant. Remember, direction is changing. It's towards center, true, but direction is not same. This is, if I say along negative x-axis, this is along negative y-axis, this is positive x-axis, this is positive y-axis. Direction changes, but it is always directed towards center. Okay, so acceleration is v square by r. It is a constant speed. I mean, speed is not changing. And speed is along which direction? Speed is along tangent. Speed is along tangent. So it means along tangent there is no acceleration. So tangential acceleration is 0. In uniform circular motion, tangential acceleration is 0, but centripetal acceleration is there and its value is constant. Okay. Always tangential acceleration and centripetal acceleration are perpendicular to each other. Always. Because this is tangent and this is along radius, and radius and tangent are always perpendicular. So this angle will always be 90. Remember, AT is perpendicular to AC, always. Okay. So in circular motion, we have one more relation. What is that? Because it's a circular motion, so we can associate angular speed also in that. Okay, so relation is V should be equal to R omega. V will be equal to R omega. Okay, so centripetal acceleration we can also write as omega square R. Centripetal acceleration we can write in terms of omega square R. Correct? So sometimes we have to do it with omega square R. So omega square R we can do. Right. This is uniform circular motion. Let's come for non-uniform circular motion. What is that? Non-uniform circular motion. Now in this one, speed is not constant. Speed changes. Okay. Speed is not constant. So if speed is not constant, means tangential acceleration is not zero. It's there. But tangential acceleration is always acting in this direction. No change. Centripetal acceleration will also be there. The centripetal acceleration. So AT is not zero. AC is also not zero. Both are there. And this one AC is not constant. It is changing. Why? Because V is changing. So AC's value is changing, but its formula is same. Formula is V square by R. Okay, fine. What about total acceleration in this case? In the previous case, total acceleration was only AC because this was 0. In this one, total acceleration is AC only. But in this case, total acceleration is sum of both accelerations. Okay, that means total acceleration will be root over AC square plus AT square. What is AC? V square by R whole square. What is AT? AT is given in different ways to you. Okay, so directly will be given, or sometimes it will be given in terms of velocity. So we will write like that. Velocity means sometimes it will be given that, okay, tangential acceleration or velocity, not tangential acceleration, velocity is given as 4t. So tangential acceleration we have to find. What's it? dv by dt. It will come out to be 4. Then we will write over here. So directly I have written as dv by dt itself. Okay. So this will be the total acceleration. In which one? In non-uniform circular motion. Sometimes they ask, they say that total acceleration, which is here, because this is tangential, this is centripetal, so total will be in between. They ask you that what is the angle this total acceleration is making with centripetal acceleration or with tangential acceleration. So what you will say? You know how to find angles now, right? So tan theta. What will be tan theta? AT by AC, what else? If they say about this angle, then it will become AC by AT. So it depends on question what they are asking. Clear? So this is how the question will be asked from uniform circular motion, non-uniform circular motion. Right. Tomorrow's class we will discuss how the questions are to be solved in circular motion. Okay. So today we are finishing here. 2D motions, your projectile motion, riverboat problem, and basics of circular motion we covered today. Okay. Tomorrow we will be solving problems on this. What? Circular motion. Right, students? So today I am finishing it here. See you tomorrow. Bye bye.